Hello everyone and welcome back to our series on microservices and Apache Pulsar. In the previous video, we set up a Django producer that sends messages to Apache Pulsar. Today, we will take it a step further by building a Django consumer that listens for those messages and processes them in real time. This video will guide you through the entire process of creating a consumer that connects to Pulsar, handles incoming messages, and integrates smoothly into a Django application. If you've been following along and are ready to complete the message flow with a consumer, this video is for you. Let's get started. To demonstrate the real-time message flow, we have created a basic Django service. This service is a simple notification system designed to simulate real-world scenarios where we need to listen to incoming messages and react to them. We begin by dockerizing our Django application to ensure it runs consistently across different environments, which is essential when working with microservices. Next, we installed Pulsar Client 3.5 in our requirements.txt file, enabling interaction with Apache Pulsar and allowing us to send and receive messages on different topics. The core of this demo revolves around two key topics, user and order. Upon receiving a message on the user topic, we will either update or delete an existing user record or create a new one in our database. When a message is received on the order topic, we will simulate sending a notification to the corresponding user. This setup simulates a real-time notification system where we react to messages on Pulsar topics by updating our database and triggering notifications. Let's now take a closer look at our base consumer, which handles incoming messages from the Pulsar topic. We initialize the Pulsar client, set the topics, and use the schemas we discussed in the last video for user and order messages. These schemas ensure our messages flow the correct format. Next, we subscribe to the topics, specifying the subscription name and schemas for message validation. By using consumer type shared, we allow multiple consumers to share the load, ensuring each message is processed by only one consumer. The message listener is a callback function triggered whenever a message arrives. It processes the message and allows us to take appropriate actions, such as saving a user or simulating a notification. Let's now look at the user consumer class, which inherits from our base consumer class. In the constructor, we pass the user topic and set our message listener. The core of the user consumer is the user message listener, where we define how to handle messages. Here is why schemas are important. Pulsar messages are typically structured, and using schemas ensures we receive the correct fields with the expected data types. This is crucial when saving data in a specific way, as the schemas guarantee the proper data format, making messages handling more efficient. In this listener, we receive the user data and check the action, insert, update, or delete. Based on the action, we either update or create a user in the database or delete the user. It's important to handle any errors that might occur during this process. If something goes wrong while processing the message, we ensure the system doesn't get stuck. That's why error handling is in place. We negatively acknowledge the message if an error occurs, meaning it won't be marked as successfully processed and can be retried later. If the message is successfully processed, we acknowledge it, signaling the Pulsar that the message has been handled and can be removed from the queue. The order consumer class, just like the user consumer, extends the base consumer class. The main difference lies in the message listener, where instead of saving the data, we handle it by sending notification to the user based on the order action. We use Celery to handle our consumers efficiently. Instead of running the consumers directly in the app, which would consume memory, we offload the task of consuming messages to a separate Celery worker. This helps optimize the main app's memory usage by running the consumers in the background. We define a Celery task in our tasks.py to initialize and run the consumers. In this task, we create instances of user consumer and order consumer subscribing to the respective topics. The task is triggered from the ready method of the app config class. This way, when the app is ready, the Celery task starts handling the consumption of messages asynchronously, ensuring that the main app isn't burdened with additional memory usage. By using Celery to run these tasks in the background, we maintain the efficiency of our Django app while processing and handling real-time messages from Pulsar. Now, let's see everything in action. We use our producer to send a message to Pulsar and then consume those messages in our consumer. First, we create a user via Postman. In the producer service terminal, we observe the user message being sent. On the consumer side, we see that the user message is received and the action is inserted. For this video, I created an endpoint to fetch the last created user. When we make a request to this endpoint, the response contains the same email we just created, confirming that the consumer is processing the message and saving the user correctly. Next, we update the same user by changing the first name. After sending the request from Postman, we see the log in the consumer terminal with the user message and the action as update. When we fetch the user, we see that the email remains the same, but the first name is updated, confirming that the consumer processes the update correctly. Now let's test the delete functionality. We delete the same user via Postman. In the consumer terminal, we observe the message with the action delete. When we try to fetch this user by their ID, we confirm that the user no longer exists in the database. Next, we test the other topic order. We send a request to create an order for the user we created earlier. In the terminal, we see the order message with the action insert. We also simulate sending the notification, and in the terminal, we observe all the relevant information: the user, the message based on the action, the order amount, product details, and the address. Now we have completed the full cycle from creating a basic producer and consumer to testing how the messages flow through Pulsar. We have seen how user data is handled and notifications are sent based on the orders. This demonstrates how to integrate Pulsar with your Django application, consuming and processing messages in real time. Don't forget to like and subscribe for more tutorials. Thanks for watching, and I will see you in the next one.